Network issue for Geo users, that's why. Sorry.
Today network issue.
Yes, ma'am, for Geo users.
Another one, students, when you're giving internal class test, you have to join in the meeting, you have to give. You should not ask the link from one of your friends and being without joining in the meeting, you cannot give. Because you're joining the meeting, your attendance will be recorded. Remember, if you did not join in the meeting, if you submit, being outside in the meeting, if you submit, of course, your submission will come, your response will be registered, but attendance sheet may your name will not be there. So it will not be considered as examination has given. Remember, don't do that mistake. You have to join. Then why honestly we are creating meeting? We can share the link. No. You have to join in the meeting and then being in the meeting without leaving, you have to give the test. Suppose because of network issue, when you're giving, you got disconnected. Again, you have to join and you have to continue. ऐसे नहीं without asking to ma'am, teacher, the respective teacher, you will just take the link from your friend and you can give the exam. No, then that will not be considered as exam. Okay. Remember, okay, for all the exam, this is applicable. Anyway, hereafter now, tomorrow and after that, you will not be giving the online exam, but I'm saying this you have to know.
Ma'am, you're on mute.
Oh, I muted. Okay, okay. Thank you. See, now this is a simple diagram which will say how the switching between the process table PCB, process control block, will happen. Okay. Here there are two processes P0, P1. Okay, two processes P0, P1. P0 here it is executing. That means it is using the CPU. Processor is now on P0. Okay. Now process is getting executed. Now P0 is getting executed. At the same time, what P1? Now the processor is not available, no? So P1 will be in idle state. Here, idle state is not the state of the process, okay? It could be blocked state or ready state. Remember, it could be blocked or ready state. So anyway, P1 is not there in the running state. P0 is currently in the running state, okay? Now some interrupt or system call comes. Interrupt or system calls. Now what CPU is busy with executing P0. That time some interrupt come to what? Some interrupt comes to processor. Or any system call. That means some process would have created the system call, because here we are considering the multi-processing system. Okay. So some other application might have created the system call that can also what? Interrupt the CPU, disturb the CPU's execution. So now the CPU will stop the execution of P0. Okay. And after stopped, where it will go? It will go to ready state. Now here, remember, process itself is not got terminated. Process is, this P0 process is having all the attributes which are required to execute. But what our CPU is doing, CPU is getting interrupted by some high priority task. So now what the operating system will do, operating system will evict this P0 and it will put that in the main memory. Okay. But P0 will continue the execution later. P0 not yet completed the execution, will continue the execution later. So till where it got executed, till where the P0 got executed, that should be stored. Okay. So that is here. When interrupt comes, where it will go, it will save state in PCB0. So PCB0 mein, PCB0 is for P0. Okay. P0 ka process control block is called PCB0. Okay. So PCB0 mein all the data will be updated. For example, state of the process, stack pointer, program counter, everything will be updated. Okay. And after updated, what will happen? Now the processes, now what the CPU will be assigned for process 1. Okay. Now process 1 will start the execution. But how it will start the execution? Till now the process P1 was idle. Okay. So this might have had happened. See, this process P1 would have executed already also, which is not shown in the diagram. Okay. So where it left, from there, it has to start the execution. No. So now PCB1, that is the PCB1 is the PCB of what? Process 1. Okay. So load state from PCB1, because now P1 is going to be executed. For that, PCB1 ka detail should be loaded. Then only CPU can continue the execution. Okay. Now P1 has started the execution. In some point, it did not complete the execution. What is happening? Again interrupt. Now where the CPU is with P1. Okay. When CPU is with P1, what is happening? Something which is very quickly, immediately, which should be executed in the P1, that is executed by the CPU. Now again switching will happen from P1 to P0. Okay. But how the processor will resume P0? For that only we have PCB. Okay. Now what, when the processor is executing P1, there is an interrupt. So as soon as interrupt came, save state in PCB1, because here half of the work got over. So till where it completed, that will be stored in the PCB1, because this is P1. Okay. So P1 data will be stored in PCB1. Okay. So PCB1 will be updated. Okay. And after that, it has to start, CPU should start again P0. It should continue the P0. Processor should continue the execution of P0. Okay. Till now, processor executed P1. So now P0 ka status already we stored here. No, that will be loaded in the memory. Load state from PCB0. After loaded the PCB0 value, then the processor will start the execution. Like that, the switching between the different processors will happen during the multi-processing system. Is this clear? Students, is this clear?
Yes, ma'am.
Confirmation required. Students, understood? Yes. See, when I'm asking anything, no, you no need to type the message and all. You just thumbs up this and all, their symbol there, no. If you do this, if you just click that, I will come to know you understood. Okay. So like that, you can confirm. Okay, this is okay. This is very simple. Now, when you take more number of processes, now this is CPU. This is, assume that this is a complete CPU time. Okay. So there is a multi-processing system, process 1, process 2. Process 1, when this arrow is what? Towards the, it is coming from out of the CPU. Arrow is coming out of the CPU. Out of the CPU. That means process P1 is evicted from the CPU. Then its state will be saved. Now this arrow shows restore P2. That means the process P2 is going to use the CPU. Okay. Now process P2 is using the CPU, and then again process to restoring the data of the CPU of the P2 to start to execute the P2, and P2 is getting executed, and in some point it is again evicted. Then its status will be stored in PCB, and then now P2 got stopped. P1 will be come to execute the CPU. So how the data will be taken from the PCB of P1? Like this, the execution will be. Here, just to understand what is the use of the PCB, process control block, which is there in the address space, we have seen this two diagram. Okay. Next, we will start thread. Okay, what is thread? You know, process is an executing instance of application. Any applications executing a particular part will be executed. That part is called what? A process. Okay, because entire application all the options you will not use at the same time. Okay, so any one you will use. Okay, one or sometimes two or three also. Okay, so whatever you are using in one application, that will create a process. Okay. For example, when you double click the Microsoft Word icon, okay, you start a process, you will start the process. Okay, when you click any of the application, for example, Microsoft Word icon, you double click to start the Microsoft Word. What will be started behind a process? A process will be created. Okay, a thread. What is thread here? A thread is a path of the execution within a process. Please listen. What is thread? A thread is a path of execution within a process. Okay, within the process, there are, for example, you are starting one application. Okay, in the same application, underline, in the same application, you are doing more than one number of tasks. Okay, you open the Word application, you are typing some file. Okay, assume that Word application is having auto save option, so automatically whenever you type a new character, it will be saved. Okay, so typing is what? Typing is nothing but getting input from the input device to Word application. Okay, and then saving is, it will be saved in the hard disk. That is another process. Okay, but this two you are doing in a single application, which is Microsoft Word. Okay, now when you enable a new application, when you start new application, that is nothing but when you double click the Word icon, you will start a process, underline process. Okay, inside the process, after went inside the process, simultaneously inside the application, whatever is started execution, all those are called threads, thread. So now you understand the definition of the thread. A thread is a path of execution within a process. Inside the process, there is a path of execution. Now the process should complete the process. There are many other subtasks it has to do. All those subtasks are called threads. Okay, we can call this as a sub-process also. Okay, remember, one process can contain multiple threads. One process can contain multiple threads. Okay. Example, you are starting the Word application. See here, the example is This is a word application, a word processor with 3 threads. Word processor with 3 threads they have shown in the diagram. Okay. Just this is a thread, thread ka symbol they have given like this. Okay, there are 3 threads where in a single application. Okay. What is the first thread is doing? It is just to keep on observing the keyboard, because keyboard, through the keyboard, in one word file may you are saving the data, you are giving the input, not saving the data, you are giving input. Okay, so this will be handled by one thread. So this thread is dedicatedly receive the character from the keyboard to the word application. What is the second thread is doing? Second thread is editing the data. Okay, another word file could have opened. Okay, keep on some data, some data the person is appending. Okay, this is inputting, this is editing. Okay, this is editing, and whenever he is edited, it is getting saved in the disk. Okay, so all the 3 are happening simultaneously. That is very important. That's why I say I took this as an auto save option. Auto save. Word may it is not there, but in Google Sheet and all, you will not click save. Automatically it will be saved, whenever you type. Okay. So like that, imagine this application has auto save option. Okay. So whenever you type, you will not click save or control yes. Automatically it will be saved. Okay. So automatically saving and getting input, automatically saving, getting input, and simultaneously in that document, the user is also doing some editing. User is also doing some editing. All the 3 are happening simultaneously. So internally, how the operating system will handle this? If it creates a separate process, one process for this, another process for this, another process for this, that is very tedious. How? Because for every process, it has to create a separate address space. Okay. When one process switch from one task to another task, this is a separate process, this is a separate process, no? So there are many things should be saved and then it has to go the other place. It will take more time and also it occupies more space in the main memory. Okay. That is why we have a concept threading. Okay. In the threading, within a single application, though you start multiple tasks, each and everything will be considered single process only, but it will be handled by different threads. Will be handled by different threads. Okay. What is the advantage? What is the advantage of threading? One is, remember, every process will have its own address space, not every thread. Okay. So all the threads in a single process, for example, this, how many threads? 3 threads. All the threads are in single application only, no? Process is single process. What is the process here? You started the word application. You started the word application. That is what? That is a process. Inside the process, you are doing many things. You are saving and you are typing, you are editing, everything. Okay. So each and everything is anyway a different process, no? Anyway different task, no? So that should be handled by a different person. Okay. That means different entity. Okay. So that is called our thread. Okay. So what is the advantage of the thread? All the threads in a single process will share the address space. Share the address space. There is no separate address space for each and every thread. Only there is separate address space for every process. Okay. So inside a single process, how many number of the threads are there? All those threads will share the address space of the process. Okay, they will share. So when they share, the switching, everything will be very easy. No, how I am saying this? See, you have to do a project or one announcement you have to make. Okay, you are in charge for some this association. You have to make one announcement. Okay, to all the classes in the college, in our college. Okay, there are many ways you can create a group, you can share that and all, you just ignore. Now assume that directly you have to go and make that announcement in the classroom. Okay, you are a single person, you have to go to several classes. Okay, what you have to do, you have to first check, you have to decide which are the classes you are going to go. And then you have to check when you're going, what time you are going to go. That time the class should be what? Free. Okay. Or otherwise that class should be started. No, some of now commerce and all will start in the early morning. They will leave 12 o'clock from the college. Okay. So you have to decide the timing and you have to ask permission to the respective teacher. All this priorly you have to do. Okay. Task is just going and announcing something. But priorly what you have to do, you have to do many things because you are going from your class to some other class. Okay. But assume that the same as announcement, you have to only make, you have to announce in your class only. Because you are part of it, no? In your class, you are a part of the classroom. So you will be already there as one of the members. It is very easy to making the announcement. Okay. There is no switching from one classroom to another classroom and asking permission. All those things are not required. Okay, like that only. Here, when the threads are there, when togetherly, when you communicate, when they communicate and complete the task, easily it will get over. Quickly it will get over. Okay. But when each and everything, like now, inputting and saving and editing, everything is created as a separate process, what will happen? Each and every process is different, no? Each and every process will have its own address space, memory. So one process to another process, when it is communicating, it cannot easily access, no, from one address space to another address space. Okay, so it will take more time. Switching will take more time. Okay, that is the main advantage of threading. Okay, but a threading based application should be very carefully designed. That is another important, because threading, all the threads in a one application are sharing a single address space. So they can overwrite one application data. The one application data can be overwritten by another thread. Okay, so that should not happen. So that application, thread-based application, should be designed very carefully. Here I end. Okay, today's lecture. The rest of the concept will be explained in the threading concept. Actually, threading, there are many techniques also. All these we will discuss in the forthcoming lectures. Okay. Okay, thank you, students. You all can leave. Batch 1 will have OS practical at 3:30. Okay, your NSM practical got over today.
Yes,
Students?
yes, ma'am, it's got over.
Got over, no? Okay, thank you, students. You all can leave.
Thank you, ma'am. Bye.
Bye. Bye. Bye to all.